Hello, my dear students. I am Aditya Chakraborty, lecturer in electrical engineering of Sri Ramakrishna Institute of Science and Technology. Today, I am going to discuss the second part of my lecture regarding the classification of lightning arrestor. So, the next type of lightning arrestor is the multi-gap arrestor. So what is multi-gap arrestor? That means there are multiple number of gaps between the rod of the arrestor. It consists of a series metallic, generally alloy of zinc cylinders insulated from one another and separated by a small interval of air gaps. So that is the multi-gap arrestor. The first cylinder, that is A, in the series is connected to the line and the other to the ground through a series resistance. The series resistance limits the power arc, or it limits the arc. By the inclusion of series resistance, the degree of protection against traveling waves is reduced. In order to overcome this difficulty, some of the gaps B to C in the figure, which we can see in the next slide, are shunted by resistance. Under normal conditions, the point B is at earth potential and the normal supply voltage is unable to break down the series gaps. On the occurrence and over voltage, the breakdown of series gaps A to B. The heavy current after breakdown will choose the straight through the path to earth via the shunted gaps. We have already stated that shunted gap means B and C instead of the alternating path through the shunt resistance. Hence, the surge is over, the arc B to C go out, and any power current flowing following the surge is limited by the two resistance. One is shunt resistance, another is series resistance, which are now in the series, and the current is too small to maintain the arc in the gaps A to B, and normal conditions are restored. Such arrestor can be employed where the system voltage does not exceed the 33 kV. So it means that type of arrestor mainly used for high voltage, medium to high voltage. It cannot be used for extra high voltage line or ultra high voltage line. So here you can see the multi-gap arrestor image. So that is the line. These are A, B, C, these are the points or the cylinder. Okay, so these are the gap, multi-gap. Here is a gap, it is a gap, it is also a gap. You can see all the gaps, and here it is the shunt resistance, and that is the series resistance, and that gaps is the shunt gaps, and that gaps is the series gaps. Okay, and you can see here the total line is earth at that point. So that is the multi-gap arrestor image or multi-gap lightning arrestor. Now, the next one is the expulsion type arrestor. This type of arrestor is also called protector tube and is commonly used on system operating at voltage up to 33 kV. So just like the previous one, that just like the multi-gap arrestor, it can be used up to for 33 kV. So it can be used for medium to high voltage also. So figure shows in the next slide, which shows the essential parts of the above mentioned or the explanation type arrestor. It essentially consists of a rod gap A in series with a second gap enclosed within the fiber tube. The gap in the fiber tube is formed by two electrodes. So there are two numbers of electrode. Okay, the gap in the fiber tube, which is formed by these two electrodes. The upper electrode is connected to the rod gap and the lower electrode to the earth. The one explosion arrestor is placed under each line conductor. On the occurrence of an overvoltage on the line, the series gap A spanned, an arc is struck between the electrodes in the tube. The heat of the arc vaporized some of the fiber of the tube wall, resulting in the production of the neutral gas. In an extremely short time, the gas built up high pressure and expelled through the lower electrode, which is hollow. As the gas leaves the tube, violently it carries away the ionized air around the arc. So this is just like a blast effect. So when this neutral gas is produced, in an extremely short time, the gas is exit from in a high pressure through the lower electrode, and which sweep or which carries away the ionized air around the arc. So the arc is extinguished. The deionization effect is generally so strong that the arc goes out and a current zero will not be re-established. So that is the principle of operation of the expulsion type arrestor. So here you can see the image of expulsion type arrestor. So there are two types of, there is a rod gap arrestor here, and this is a fiber tube. We know that fiber tube, there is the internal gap, and these two electrodes are in the fiber tube, as we have already discussed, and that is the horn gap. And there is also the protector tube. We know that type of arrestor is also known as the protector tube arrestor. So there is the protective tube, there is the horn gap, and there is the conductor. So this is the image of an expulsion type lightning arrestor. So now advantage and limitation of expulsion type arrestor. So these are the following advantage. So number one, they are not very expensive. It is very much advantageous. They are improved form of rod arrestor, as they block the flow of power frequency, follow currents. They can be easily installed. These are the advantages. And now the disadvantages or limitation of expulsion type arrestor are as follows. An expulsion type arrestor can perform only limited number of operations, as during each operation some of the fiber material is used up. So when the fiber material is finished, then it cannot be operated. Okay, so that is the big disadvantage of expulsion type arrestor. This type of arrestor cannot be mounted on enclosed equipment due to discharge of gases during the operation. So it must be open, otherwise it can't be operated. Due to the poor voltage by ampere characteristics or the voltage by current characteristics of the arrestor, it is not suitable for protection of expensive equipments. So that's all for today. Thank you.